Okay. Let's wait for a moment for people to join in.
Mm-hmm.
Okay, good afternoon, good morning, depending on where you are. Welcome to today's Gala webinar. My name is Isabella Massardo. I'm a content strategist here at Gala. And the topic of today's presentation is large language models, a new era for localization. We're going to start in a moment. Let's just give people time to log in. So please sit tight. And in the meantime, maybe you can write in the chat and tell us where you are joining us from and whether you have any big question about large language models. I'm sure our speaker is game for Ask Me Anything. Okay. See, there are still people logging in. Let's give it a bit longer. Okay, well, let's get started. As I said, the topic for today is large language models, a new era for localization. And you can see the speaker is already here with us, Andrzej Zydroń, CIO of XTM International. He has worked in IT since 1976, apologies, Andrew, and has been responsible for major successful projects, big companies like Xerox, STL, Oxford University Press, Ford of Europe, and much more. And he's extremely involved in a wide variety of standards projects and open standard technical committees, and is currently head of the OASIS OAXL technical committee. And if you wonder what that means, OASIS OAXL stands for Open Architecture for XML Authoring and Localization. As you know, the webinar will be recorded. I will send the link to the recording as soon as it is available on our website. We're going to have a Q&A at the end of Andrew's presentation, so feel free to submit your questions using the QA box. And I would invite you to send your questions throughout the presentation as you think of them. Andrew, I'm going to leave the floor to you.
Many thanks, Isabella. Hello and welcome to today's Gala webinar on the topic of large language models and the impact that this AI technology will have on the future of the localization industry. Okay. As you are by now aware, there is big change coming to computing in the AI space. It has the potential to have a dramatic effect on the direction and technology, such as we have not seen in over 3 decades. Based on the availability of enormous volumes of data available on the internet over the past 20 years, as well as digitized books, large language models based on the latest AI algorithms are producing incredible results in terms of text generation. This not only covers basic question and answer queries, but also translation and natural language processing. We are at the start of the journey with large language models, with many more improvements in terms of quality and performance to come. This will have a significant impact on our industry, potentially replacing human translation in most instances. So a good starting point in tackling AI is basically exactly what is intelligence. And a definitive definition of intelligence was provided by Jeff Hawkins in his seminal publication in 2005, titled On Intelligence. Hawkins defines intelligence as comprising 3 components. Firstly, the ability to recognize patterns. Secondly, the ability to store knowledge of those patterns. And thirdly, and above all, the ability to use that knowledge to predict and influence future events. So what are patterns? Well, patterns are everywhere. And they're all around us. Any repeating characteristic or event or behavior. Nature is made up, in the most part, of patterns. We have patterns of seasons, one follows the other, spring, summer, autumn, winter, day following night is a pattern. We have patterns of behavior, patterns of relationships. We also have language patterns. We all talk, every single human being has their own unique patterns of language that they use. So what is language? Obviously, human language can only be understood within a human context. According to the great linguist and cognitive psychologist, Professor Steven Pinker, language is a window into human nature. It's infinitely flexible, full of contradictions, messy, constantly evolving, and more often than not, based on acquired conventions. It is a very important and fundamental tool for social differentiation. It is by no means scientific. Words basically mean what we want them to mean. To quote the Mad Hatter from Alice in Wonderland, and this is absolutely true. Words change meaning over time. Take gay. When I was a child, gay meant happy. Now it's a euphemism for homosexuality. So we have this complete change in the use of one single word, and this carries on throughout our use of language. Language constantly evolves. Its compositionality means that it has infinite capabilities. It's made up of the basic building blocks, nouns, verbs, obviously, as we know. Those are the fundamentals. Everything else is just designed to add to the mix. Various components can be combined in whatever form appropriate to convey meaning. So how do we start addressing this very complex and messy event in computing terms? This language is replete with patterns. Every human being has unique speech patterns, in addition to the frequent stock phrases that we all use. To understand what's being said, we need to know the context of which it's being said in. That's the fundamental issue. So the key driver for innovation in this field has been Google. Google was faced with the problem of how we can begin to understand what a user is searching for outside the primitive keyword search. So if we go past primitive keyword searches, Google wanted to improve the way in which search happens, the way in which it can understand. And the key thing is understand search. So bearing in mind that everyone has their own way of expressing themselves and infinite flexibility of language, this would appear to be an impossible task. Another problem is that our current generations of computers are based on a 75-year-old design. Basically, when you strip down our computer architecture, nothing's changed in 75 years. It's as John von Neumann with Alan Turing designed the prototype computers back in the mid-1940s, nothing's changed. And although this has served us well, it's not, and is ideal for databases and spreadsheets and that type of administrative applications, in no way reflects the way in which the human brain works. Our human brain works in a completely different manner. We use a concept called neurocortical computing, where a lot depends on the connections between the neurons in the brains. And this in no way is similar to the way in which computers work. Anyway, back to Google. The breakthrough happened at Google and was based on a technology called vectorization. This happened around 2013 with the publication of the Word2Vec paper. A very simplistic description of vectorization relies on processing a large corpus of text, and after applying a unique value to each individual word, new identifier, you then build an array of 300 plus vectors, the most common words preceding and following that word. So basically, we start with an enormous corpus, and we'll keep on going back to the common crawl. I mentioned common crawl quite a few times. This is a crawl of the whole of the internet. So we extract the words, we give unique identifiers to the words, and then we push this into a neural network, and this is where magic happens. We build an array of 300 values of the most common preceding and following words. So these vectors are also known as embeddings, and they use algebraic cosine values. It's quite complex, but this is where the magic continues. Vectorization gives us the ability to highlight hidden relationships between words. So we can say, what is the word most similar to a word? So in this instance, in the example we have, we are using vectorizations. We're using a Python method here to tell us from the corpus what are the words most similar to THX, which is a shorthand for thanks in emails. And basically it answers with those that are closest in their numeric value. This is quite incredible because these embeddings allow us to group words, similar words together automatically, or as I say, automagically. You shall know a word by the company it keeps, quoting John Rupert Frith. And this is so true of human language. And the magic continues. You can start doing mathematical calculations based on the embeddings. So the example is if we take king and subtract the vector for man and add the vector for woman, we arrive at pretty damn close to the vector for queen. So we can start using mathematical equations to find out which words are affected by gender. But it also is weirder than that. You can take the vector for the sound in English, onomatopoeic sound that a cat makes, meow. If you take away the value for cat and add the value for dog, you get woof, which is the onomatopoeic word in English for barking, for a dog. So this was actually an important starting point. And in XTM International, we use vector space a lot. We use basically the vector spaces that have been provided open source by Google and Facebook. Each language has its own vector space, its unique fingerprint. So say word for chien in French will not be the same as dog in English. And a lot of our work was providing an interlanguage vector space, which enables us to map words from one language onto another. And we use this for a variety of tasks, including the automatic placement for inline elements in our XTM workbench, for automatic terminology extraction, bilingual terminology extraction, computer-assisted review, etc. So it's a very, very core and important technology. So what are large language models? Large language models are, in essence, massive neural networks that are trained on a very large corpus. They predict what word would normally follow the current word based on the current context. E.g., the preceding words, in essence, that is all that they do. When you break down, use Occam's razor for large language models, all the computer scientists will tell you that's all they're doing. They're just predicting the next word, but it's actually incredible how they can do it. In essence, the secret is the data that's used to train these models. The final breakthrough that allowed large language models occurred in 2017 with the publication of the paper by Google Research titled "Attention is All You Need." This showed how vectorization could be used with a new transformer algorithm to automatically generate text based on context. So transformers and vectorization had a big impact on neuro-machine translation. Back in about 2016, we saw the advent of neural machine translation, and it was a massive improvement on statistical machine translation. It had drawbacks, though. You needed an awful lot of parallel text in order to generate the neural machine translation engine, but also it was fairly brittle in that you couldn't update it easily. It struggled with words that it hadn't encountered, and training would take an enormous long time. In 2017, with the publication of the Attention is All You Need paper by Google Research, and this was the reason for the Attention All You Need paper, was basically his final way of being able to understand what a person searching on the internet really wanted to say. So transformers are much more efficient, more productive than the long short-term memory algorithm used in neural machine translation. And they have a lot of improved features over neural machine translation. And more likely than not, they will and are replacing in many instances now neural machine translation engines. So let's move on to the next slide, which is about OpenAI. So by now, absolutely everyone will have heard about OpenAI. Founded in 2015 by, amongst others, Elon Musk and Sam Altman, OpenAI has undergone several transformations, dropping its initial cybernetics division. It released GPT-3, a truly impressive large language model, to a restricted audience in 2020 to universal acclaim, but with a strong proviso concerning unacceptable outputs depending on prompting provided. You could get it to output really unacceptable, both in terms of sexist and racist output. Unfortunately, and we'll have a look at what goes into training a large language model. As I mentioned the common crawl. The internet is full of texts of dubious nature. Basically, anyone can publish on the internet, and nearly everyone does publish in one form or another. And you can't actually believe or trust a lot of the text there. But this wasn't the goal of large language models. Large language models are there as text generation engines, not as a single source of truth. That's the important message to get over today. They are not a source of truth. They are text generators, but they are incredible in what they do. Okay, the main important things to note about OpenAI, the real core issues, the core characteristics, the main things with OpenAI is the main secret source of the original GPT-3 was hiring lots of Google AI NLP engineers. So that gave them a good head start. Most of the core theoretical work came from Google and from open source. There's been a massive amount of fantastic open source research done on this. And GPT-3 was trained primarily, as I mentioned, on the common crawl, which basically not limited, but obviously affected the way in which the release of the original GPT-3 occurred. OpenAI became very afraid that in the wrong hands, this could be used as a very negative tool. And to this day, if you're signing up for quite a few of these models, they will have a clause which says that you won't use them for nefarious purposes. So these models are text generators, not a source of truth. Their role is to generate text based on prompting. all large language models suffer from the Dunning-Kruger effect. They will always try and answer the prompt, even if they do not know the correct answer. In street English, they blag. Okay, if they don't know the truth, they try and make it up. Having said that, they do linguistic tasks really, really well: spell and grammar checking, translation, terminology extraction, etc. So what goes into actually create a large language model? This is a table of the data sets that went into training GPT-3. So we have, above all, the web, the common crawl of the web. We had web text 2, which is also web, but with much higher authority, much higher weighting. And these are, above all, Wikipedia, which is a well-known, kind of well-regarded source of truth, and also Reddit articles have had more than 3 upvotes, I think, or is it more than 2 upvotes, something like that. But also a lot of books, a lot of digitized books, the Gutenberg projects, Bibliothek, and as I mentioned, Wikipedia. So these are the things that large language models were trained on. For GPT-4, I'll mention that in the next couple of slides. OpenAI stopped releasing the information as to what went into train them. So the journey between the pace of progress from 2017 through to 2020 to now has been accelerating massively. The journey between GPT-3 and ChatGPT, ChatGPT is in between the GPT-3 and GPT-4, really was a long exercise that OpenAI did with the original GPT-3 called RLHF, Reinforced Learning Human Feedback. So they hired an army of people to provide feedback on the prompts, on the answers to various prompts from the original GPT-3. Whereas the GPT-3 could produce what would be unacceptable output for most people, the team of, well, sorry, not volunteers, but they were paid, the team of people reviewing the answers would give feedback to OpenAI that this is good, this is bad, and that was the reinforced learning. So they added a layer to GPT-3 which was designed to remove unacceptable output. The pace of development, as I mentioned, is astounding. It's a boiling cauldron of creativity. All of the best minds in the world, artificial intelligence experts and researchers, are producing a constantly improving level of output. Obviously, OpenAI only one of the players, but they have been first to actually allow access in a meaningful way to the data. They provided a straightforward commercial API, which is readily understandable and relatively easy to use. And that's above all been their main success strategy. They've allowed they've allowed the language models the OpenAI GPT models to be accessed in a simple, straightforward, understandable manner, and commercially successful in terms of being able to cover their costs. One should note Bard, which is actually not on here, but Bard is based on Palm. This big blue model here is Google's Palm. It's now being promoted to Palm 2. that actually powers Google's Bard. Anthropic's Claude is a very interesting model. We now have Claude 2. This is the state of the art in March. We're now in July. Things have actually progressed at an incredible breakneck speed since then. We now have Claude 2. The interesting thing about Anthropic is that Anthropic is really an offshoot of OpenAI. A whole load of engineers from OpenAI left to create Anthropic, and that's showing really good progress. And rumor has it that Apple are working on Ajax, which is their own large language model, which will be integrated into iOS and macOS in the coming releases of iOS and macOS. Microsoft has chosen the route of partnering with OpenAI, and they actually have integrated GPT 3.5 and the ChatGPT and GPT-4 into the Bing search. So the amazing thing is that there's no sign of plateauing. Things are just getting better and better all the time. What we're seeing, the latest trend is not necessarily the size of the parameters, but GPT-4 apparently 16 different submodels that all negotiate between themselves. So we're seeing a transition from the size of the models to more productive ways of using the models themselves. I think we've kind of exhausted all of the text available that's actually accessible in terms of books and the internet. So the next developments, the next progress seems to be more intelligent ways of using that data. What I haven't mentioned so far is that these models, especially GPT 3.5 and GPT-4, are fantastic at generating computer programming language. So you can tell it to create a Python or a Java method or function. You can get it to convert from a Python method to a Python function to a Java method. You can get it to create complex SQL queries for a database. So they're not just limited to language. And also, there's been an awful lot of work on automatic image creation, like DALL-E from OpenAI, Midjourney, as a whole load of recent models that we see that actually can create videos now, animations. Someone's actually created a whole South Park episode with one of these models based on using the same characters and the same sounds, same voices as South Park characters. So it's quite incredible. When it comes to standard tests and exams, GPT-4 is astounding in the way in which it can beat humans, not only in the tests, like the Bio-Olympiad, the maths grades, law, but also remember all the films where computers and robots were shown as having no empathy and no understanding. The classic one is Arnie Schwarzenegger in The Terminator. Well, in terms of theory of mind and empathy, GPT-4 scores 100 in empathy tests. We puny humans manage on average about 87. So that's another thing that science fiction films got wrong. These systems can be a lot more empathetic and much better at theory of mind than the average human being. which is slightly frightening. So if we summarize, large language models are the latest advance in AI NLP, and they will outperform neural machine translation systems. Intento, the California-based company which provides automated routing for various machine translation systems, ranks now GPT-4 on par with the best current machine translation systems. And they can only get better. And in fact, I suspect, and is strongly suspected, that DeepL and some of the better models, neural machine translation engines, are using transformer architectures as well. They're using elements of large language models already. So rather than training on bilingual corpus, they use all available text from common crawl of the internet and more, primarily designed for text generation. The neural network engines then work out everything, including translation between, I mean, it's anywhere between 130 and 175 languages that have at least a reasonable presence on the internet. I could answer questions in any language, any topic, and can generate text and write articles in 175 language, can code in multiple programming languages. So what can they do in terms of our localization space? Well, they can obviously do question answering, semantic parsing. They can create proverbs, arithmetic, code completion, general knowledge, reading comprehension, summarization, logic inferencing chains, common sense reasoning, pattern recognition, translations, dialogue, joke explanations, physics QA, and language understanding in terms of the limits to which they can do that. Their overall performance, and I'm not talking now just about OpenAI systems, but also systems from Google, especially, and I've forgotten to mention Llama and Llama 2 now from Facebook, which has just been released for open commercial use. These systems are quite incredible. About 6 months ago, an engineer from Google was put on farming leave for claiming that one of Google's models was sentient. And there is a very good video on YouTube that you can view. The engineer actually has something like 20-minute conversation between this model, which is voiced using voice synthesizer, and I would challenge you to say that it isn't sentient. It certainly gives the impression of having self-awareness. So we're living in incredible times. So we've mentioned GPT-4 in terms of translation. We can see that just in terms of the breadth of language pairs, and I've done extensive testing between my own native languages. I have two, being bilingual from birth between English and Polish, and then French, where I had the great privilege of living there for 6 years in my youth. The fluency is astounding. Google's Bard is catching up quite quickly, but it was initially limited to English to a very large extent. That's improved its multilingual capabilities. Google have been quite slow in actually catching up, but they are now gathering pace to actually compete more directly with OpenAI, and we'll see over the next 6 months where things go. But the implications for just generative text for, say, automatic translation on holiday, for hooking up into apps on smartphones, etc. They've gone past just the basic of where is the station, what can I do. They can actually move towards doing incredible understanding and response to complex questions between one language and the other. So we're in the able of Babelfish and the Hitchhiker's Guide to the Galaxy, almost, in terms of what these systems can do for us. So what can GPT-3 do for localization? Obviously, we've said about how can we use them as tools. That's the key thing. Forget the text generation, forget everything else. How can we use these things in localization? Because that's the most important thing. So apart from the translation between 30,000 different language pairs, we can do anonymization. So you can tell large language models in the following text, please tell me which words have personal identifiable information, any values, dates, or addresses, and actually will provide, say, on a legal document or an email or a document being translated, it can actually return all of those values, and we can then use those actually strings to anonymize those strings, where it's a confidential document where the translator, it would be better if the translator didn't actually know the values, the names of the person. So it may be a legal document that is very sensitive and confidential. So we can use it for anonymization. We can do summarization, which is really useful for translators. These models do brilliant work on summarization, fantastic. You can actually ask it to compare the quality between different translation engines. It can also actually do grammar checking. It can do gender conversion. So in a gender-specific language, the machine translation engine, if you've used one, could have put everything in the male voice. But this may be a translation that is female specific, where the audience would relate to a female character rather than a male character. And you want to change the translation into a female voice. Does that fantastically. So Polish is very heavily gender-specific language. There are 3 genders, masculine, feminine, neutral. So this is a very common thing when you're translating into Polish from English, where you want to actually appropriately color the output for a given gender. Computer-assisted review, you can actually ask the large language model, say, is this a good translation? Or is this a valid translation? And it does a very good job of quantifying whether the translation met a certain threshold. Fuzzy completion, one of my favorites. So we all know fuzzy matching. We all know that fuzzy matches will have a number of words that haven't been translated. Well, you can ask the large language model, okay, given that sentence A is the translation for sentence B, please can you provide me the proper translation for the updated version A segment? And it will do the completion for you. So we can reduce the amount of work required by a translator. We can do terminology extraction as well as bilingual terminology extraction. So given a corpus, we can actually tell it to extract terms, noun phrases, and at the same time tell us what the corresponding nouns and noun phrases are in the target language. So you can do automatic terminology extraction, which can then be reviewed by a linguist to create a terminology database for that specific document type. We can do language appropriateness tests. So is this language appropriate in terms of the audience? Is it possibly inappropriate? Is it sexist or whatever? We can actually get it to generate alternative translations. So for, say, marketing, for marketing materials, we can ask it to provide 3 or 4 variants on the current source. And not only that, but you can also, and this is the brilliant thing about large language models, which can continue to blow me away, is that you can say, okay, translate this sentence for me as if you were a teenager, or as if you were a mature person. So you can actually get it to voice the translation appropriately. And you can get it to generate content, if just rather than lorem ipsum est type stuff for just testing. So what do you think the impact of large language models will be? So conclusion, we know the big change is coming. The pace of change is dramatic. Really, I can't underline. Bill Gates said when he saw ChatGPT, this was only the second time in his life that he'd seen a computer demo that made his bottom jaw drop. The first one was when he saw the Xerox PARC mouse, icon mouse WYSIWYG interface. It's the large language models were the second time. We can expect human quality translation from large language models. I think that's a given. Large language models plus post-edit plus CAR, computer-assisted review, will be the main emphasis for us in XTM. Human translation will gradually fade with time. Large language models will be restricted to very large players because of the high barriers for entry. Forget the open source models. Maintaining these models, providing enough computer power to power them, and also providing enough safety in terms of language appropriateness, etc. This is only for the big players. Researchers can play around with open source models, but they really are not. That the computing required at the moment is just past the capabilities of individuals. As far as we're concerned, as a translation management system provider, we embrace large language models with full enthusiasm, as we do all the heavy lifting. Translation's the easy bit. In a translation management system, we provide all of the connectors, the filters, the workflows, all of the management of the previous translated material, etc. If you take it in terms of the volume of lines of code, XTM is around about 5 million lines of code. A large language model is about 1/10 of that. Granted that the key ingredient for large language models is the volume of text and how you train the model, but in essence, they are the easy bit. Providing a translation management system is difficult. So we embrace large language models with complete enthusiasm, and it allows us to offer our customers environments where the cost of localization will continue to fall. And it can only be a good thing because there are never enough translators to provide translation for all the materials that are out there. And for the demand for localization exceeds the number of of available translators. So it's time for question and answers. Thank you for bearing with me so far. We've been
Thank you
going
so
for
much,
45
Andrew.
minutes.
Thank you so far. Thank you so much, Andrew. That was a brilliant presentation. Let's see whether there are some questions coming in. Let's give it a minute. I understand that you're very, obviously, very enthusiastic about this development. And
Yes.
when you were talking about it, I had to remind myself of what I usually read, articles by, I don't know, Emily Bender or Timnit Gebru or even Melanie Mitchell, who are actually warning us against ChatGPT and all the frenzy that is surrounding this technology. But you provided a very unbiased and
it's coming, and it's like with King Canute and the waves. There's no way avoiding it. So the best way is the same tactic as with a tsunami. You have to ride the wave, otherwise you're going to get crushed.
Let's see if there are questions. I think everybody is just in awe of your presentation.
No. You're too kind.
How much is the work of LSPs going to change? Because of course, I mean, XTM is integrating large language models and developing new features, etc. But how quickly can they be accessible to LSPs of all sizes?
Okay, so this is the $60,000 question.
Sorry.
LSPs do not translate; they manage translation. Which is a difficult task. So the intellectual property of an LSP is first and foremost the list of translators, trusted translators. I see translation moving much more towards a post-edit and a reviewer role rather than straight translation. And the role, it's translation management systems already provide a high degree of automation. If you look at the TMS such as like XTM, we kind of automate 60 to 80% of the standard tasks that the project manager would need to do. And these are the kind of the boring, repetitive tasks. So it's basically getting the source material, filtering the source material, running it through a translation memory and terminology, and then passing it on to the translator, actually finding the translators, locating the translators, engaging them, and then managing them so that they actually complete the translation on time. I can see that aspect, the translation bit, we've automated the PM role to a large extent. And a lot of our customers now have completely automated systems where we hook into a CCMS or a web CMS or a source control system like Git, AEM, etc. A new text is pushed out automatically. Something's updated, no human intervention. It goes to XTM, it gets processed, and then gets output at the final part to translation or machine translation, then review, and then goes back automatically. So if you automate the translation bit, you kind of remove a lot of the role of the LSP. The only thing the LSP then provides for large customers is a guarantee that they will provide, in the end of the day, a reliable service, regardless of what is happening at the back end. So they are always a guarantor, because in the end of the day, the customer expects the LSP to perform its role. So the LSPs, we will never get engaged with doing translation. Certain translation memory management system providers also provide translation. We'll never do that. But I think their role will change. to encompass an ever-increasing level of automation at the translation end. Stage one has been automating PM work. Stage two becomes actually automating the translator work. There will always be types of translation that require human intervention, especially in life sciences, in legal, where final review where the criticality of the documentation is such that you have to have a human being to sign off. But human beings, as I well know, and the older I am, the more and more I am aware of it, we are incredibly fallible. And I rate a human being as about 75% reliable in most instances. As a father of children, if you have any children, you appreciate more and more the unreliability of human beings. So we have our limitations.
There are a couple of questions. I think to some of them you already replied, but I think it's good just to go over them once more. So first of all, a question from Devi. What is your advice for human translators with no tech experience to skill up or expand their knowledge base?
I would say expand your knowledge base and get much more into correcting and review. The downward pressure is always on cost. And this has been true from the time I first got involved with localization in around about 1990. Translation costs have always been on a downward slope with the pressure. And quite honestly, most probably getting much more conversant with reviewer tools and things like that. That's probably the best solution.
Okay. Let's take a couple of more technical questions. The list you gave of items where large language models would be useful for localization contains mainly use cases where the large language model is applied to a complete document. But in translation environmental tools, the translation is segmented, mainly sentence-based. How do you envision bringing large language model features to the segment-focused translation editor?
Very simply, you train the model, which is something I haven't mentioned. So these models train very easily and quickly. So you train it on the corpus. So you train it on translation memory. You can also, theoretically, there's nothing stopping you training it on the fly. So as a translations update, all you do is you tell the large language model, use this actual customized model. So what a customized model is the main model plus the training. So these things are incredibly intelligent. You just tell it, okay, translate it using the model that's been trained on the previous translation. So use the same style. Obviously, translation memory will always be there because you don't want to send data out twice. So you use above all what's been translated before. But then if you've trained the model on your data, you just say use the trained model. And you can give it, obviously, you can give it context as well. You can give it the context of the preceding, say, 5 or 10 segments. These things are not easy to defeat.
Okay. Well,
they're not just single segment based. These are very, very sophisticated linguistic tools. Don't think that they're very straightforward. They're not.
They're much more capable. They're capable of much more.
I give you an example of some of the things that just blew me away. Just the sheer linguistic capabilities. I sat down and asked it when I started off with GPT-3, back before all the hubbub about ChatGPT, I said, okay, write me a simple poem about the sunshine or, flowers, which Trundles often does that. I said, then, okay, give me that poem as if it was written by Locke. Okay, goes by. Yeah, perfectly. I said, okay, do this as the same poem as a Shakespearean sonnet. Bingo. Okay, so now do this in Middle English. And it came back in perfect Middle English, from the time of 14th century, 15th century, Chaucerian English. And took me a long time to actually lift my bottom jaw up off the floor. These things are unbelievable.
Yeah.
Yep.
Let's take some more questions. So as a current user of XTM, Marianne is asking, is this TMS ready to leverage large language models today instead of empty engines?
It will be, according to our product director, Sarah Brasile, who I must obey, and who is the keeper of the roadmap. We will be releasing some features in beta in 2024, early 2024. We haven't rushed in. We've been doing various other bits around XTM, but you will see features in 2024. It's not always good to rush into these things because in an environment where things are changing so quickly, you need a certain state of maturity in terms of the API and reliability. OpenAI did suffer from reliability issues in terms of the throughput when ChatGPT was released, and everybody started using it, and they didn't have enough computer resources, and everything ground to a halt. We need to get a production ready system available from OpenAI. We're getting there, and we've seen big improvements. OpenAI are still experimenting. There has been a slight deterioration over the last few months in the quality of the output from GPT 3.5, which powers ChatGPT and GPT-4. They've been adding extra safeguards. Those extra safeguards have resulted in a drop in sometimes the quality of the output. So it is a bit of a moving target, but certainly we aim to provide the most reliable and professional service, and we estimate that OpenAI will be there within the next 6 months, at which point we will be releasing. We have the beta code. I've actually written a lot of the code already. Yes, I did that in January and February, but we're waiting for OpenAI to become production ready for kind of serious use for customers.
Let's take a couple of other questions because we only have a few minutes left. So another question is, what are the top languages that are integrated with the AI? The ones that you can trust the quality.
I would say that the top 50 languages on the internet are, the quality is astounding. I say the Polish right from the get-go was brilliant. And its ability to do change the voice gender, and to do just grammar checking and spell checking is it's just phenomenal.
So basically, let's just go and test them depending on your needs.
We've done Arabic. We've done a lot of work, obviously, with German and Italian. But
I'm
the
going to
top
take
50,
one more question, if you
Yep.
don't mind, because
no problem.
time is almost up. But there's another question. Let's see. How can AI make a change for the whole LSP departments, not only on the linguistic level? Do you have any recommendations for apps that worked with internal departments?
You can the CCMSs are and source code repositories like Git, AEM, Marketo, all of these, you can totally automate the translation.
Okay.
So from start to finish.
Okay. Quick one.
Depending on the material. Yes.
Okay. Another quick one. Let's see. What role does confidentiality play with large language models?
Okay. OpenAI has a very good SLA. So if you're paying, and I must emphasize, if you're paying, you are guaranteed confidentiality. Any models that you train, any data that you put through is covered by the confidentiality agreement. I would suspect the same would come from Google and Bard. And I sense that Google will, in 2024, equal and possibly Google has the potential to surpass OpenAI in a couple of spheres, especially their DeepMind research unit, which OpenAI don't have an equivalent of. And I haven't touched on DeepMind and on the other capabilities. Be afraid, be very, very afraid.
Well, we'll invite you back for a talk on DeepMind and the new things coming.
It will be a pleasure.
Okay. I'm sorry, everybody. I need to close the session, but thank you so much, Andrew. It was a pleasure listening to you. Thank you to everybody who attended and asked questions. We're going to take a little break in August, but we have two great webinars coming up at the end of August. We have a webinar on all things automation with István Lengyel from Be Lazy. And this webinar will take place at 10 a.m. My time, so European time, and it's a special webinar that we're doing for our friends in Asia Pacific, in the Middle East, because they usually cannot attend our webinars because it's the middle of the night for them. And on August 31st, we have the Dell's team presenting their accessibility journey. So hope you'll join us then. And in the meantime, have a great summer. Andrew, thank you again. Please come back and present again.
My pleasure, Isabella. Thank you.
Okay.
Thank you, everyone.
Bye, everyone.
Thank you. Bye. Bye.